Okay, let's really look at this next question 3 because people have been having a lot of problems with that on the feedback problems. Okay, so what are the things you're looking at when you're looking at a limit? Okay, well, you want to know where's the x going. Can you see that's the ends? So you're like end behavior. If end behavior is a constant, so if you're headed towards the right, you level out at 8. If you're headed towards the left, you level out at 1. That tells you that each of those is a horizontal asymptote. Okay, what about the next one? This time, you're headed to a constant from one direction, and the output is an infinitely big or infinitely small number. So that tells you you've got a vertical asymptote. And that's at x equals 4, because around 4, x behaves like a line. Okay, let's see about this one. Okay. When you're approaching 2 from the right, you get 3. But if you're approaching from the left, you get 4. So you're like, going this way, I'm at 3. Going this way, I'm at 4. It's called a jump discontinuity because you're jumping the outputs. Okay, let's see the next one. Up. We're going to the same spot. I should have a plus and a minus there. Okay, and you're out, and you think you're going to hit 3, and at the 10 you do hit 3. So you just got a nice point there. You're like, oh, just everything's normal there. So at x equals 10, the function f is continuous. Okay, now this next one's a little different. From 6, but this time you think that you're going to hit 3. But the output's 4. This one, you think you're going to hit 3, and the output is 3. So this is called a removable discontinuity. Where at x equals 6. Okay. Okay, now if you try the last one, that's revisiting that numeric limit. So you should take this function and put it in your calculator. I'm going to write it like you had an old-fashioned calculator. You would need e to the 1 plus x minus e over x. And from the home screen, you're going to check some values. So we're going at 0 from the plus. You're going to put in like 0.001. This would be negative. Then when you do this one, you do the same thing, but you'd have to change that to 2. Okay, so when I did that, I got these decimals, 2.718. I'm like, oh, 2.718. You guys notice? That's the number E. And then when I do the next one, I'm thinking, oh, I got 7.389, about the same thing here. I'm thinking, oh, wonder what that could be. Did anybody figure it out? That is E squared. Yay, cool. Next year, you're going to learn that the derivative of E to a power is E to the power, which is super cool. All right, think of me when you learn that.